All right, hey guys, today we are going to do lesson 5-4, and the lesson is on comparing functions. So you need today your math book, your notebook, and a calculator out and ready to go. All right, so let's just kind of quickly review. What do you know about functions so far? Can you tell me the definition of a function? How do you tell from a table if it's a function, and how do you tell from a graph? These are all things that we worked on. So take a minute, pause the video, and think about each of those three questions. All right, so definition of a function is if you put something in, you get one output. So for every input, there's exactly one output. From a table, you guys should quickly be able to tell. If I put in a 3, I get a 5. If I put in a 4, I get a 6. If I put in a 3 again, I better get a 5. Okay, if I put a 7, I can get a 6, but every time I put in a 3, I better get the same output, which is 5. So that's how you can tell from a table. From a graph, we learned about something called the vertical line test. So again, if I have a graph and I want to know if this is a function, if you draw a vertical line, it passes once, so yep, it's a function. All right, if I drew one that's not a function, maybe like this, if I draw a vertical line, it crosses twice, so there's two different outputs there. So no, that one is not a function. All right, and then last week, we also learned about linear functions and how to find the slope and the initial value, which is another word for y-intercept. So again, we learned the rate of change and the initial value. All right, so an example of what we did last week, just as a quick refresher, is I might give you a table and I am telling you how much money I saved after a certain amount of months. Okay, so I'll say after how many months and then how much money I had. So I'll tell you that I started with some savings. So I started with some money. We don't know what that is. That's called the initial value. So we want to know, how can we find that? So the first thing that we did was we found the rate of change. So just as a quick refresher, we did the y's, the 370 minus 250. We saw how much my money went up and how much my months went up. We did 11 minus 7. So we subtracted the y's, subtracted the x's. So when I do that, 370 minus 250, I get 120. And then 11 minus 7, I get 4. And then 120 divided by 4 is 30. So that means my rate of change is 30. Okay. And again, I can see that here. It went up 120 and it went up 4. So then I did 120 divided by 4 is 30. So that actually means that I am saving $30 per month. Okay, that is my slope or my rate of change. The next thing we did was we tried to find the initial value. I want to know how much money did I start with. So we wrote the equation y equals mx plus b. This is a good refresher from last week. Okay, we started by filling in, well, the slope is 30. Okay, I don't know my initial value. That's the b. I do know one x and y coordinate that I could fill in. So I could just take either of these numbers. I'll take the 7 and the 250. You guys might see I'm circling that. I'll plug a 7 in here for x, a 250 for y, and then I solved it. Okay, so if I do 30 times 7, I get 210 plus b equals 250. And to get that b by itself, I'm going to subtract 210. So I end up with b equals 40. So that means my initial value was 40. That's also another word for that is y-intercept. So my final equation is y equals 30x plus 40. That means I saved $30 a month and I started with 40. If I was going to graph that, I would be starting at 40 because that's my y-intercept, and then I would be going up 30 over 1, up 30 over 1. And then I would go ahead and graph that linear function. All right, so now let's go ahead and get into today's lesson, which is on comparing functions. So open your math book to page 285. Our learning goal is that I can compare functions that are represented in different ways using their initial values and their rates of change. All right, so on page 285, we've learned that functions can be represented by a table. So here would be a function represented by a table. It can be represented by a graph. And it can be represented with an equation. I could write something like this. Or it could be represented by words. Okay, so today we are going to kind of be comparing functions. We're going to be looking at like their initial values. Then we're going to be looking at like how much it goes up, their slope or the rate of change. And we're going to kind of be comparing them and seeing which one has a greater initial value, which one has a greater rate of change. So our first problem is on page 286, and we are going to be comparing two functions. So let's go ahead and start reading through this one. It says the function m equals 140h. Let's underline that. Where m is the miles. Okay, I like to underline that. And traveled in h hours. Okay, and that represents the distance traveled by the first Japanese high-speed train. Okay, so that's the Japanese one. Now, I also have a high-speed train operating in China that's shown in the table. And it's going to tell me that both of these are linear. Okay, so the Chinese one is in the table, and the Japanese one is on the equation. So it says compare the function's initial values and rates of change. Then determine how much further the Chinese train will travel than the Japanese train if you ride each train for 5 hours. Okay, so kind of a lot of steps to this one. All right, so first it says compare the initial values and rates of change. Okay, so if we look at the first sentence, it says at 0 hours, no distance has been covered. So the initial value for each function is 0, it looks like. Okay, so they haven't gone anywhere. The rate of change for the Japanese train, okay, that would be this equation here, is, well, it kind of shows us 140 miles per hour. The rate of change for the Chinese train is how many miles per hour? Well, if you guys look at the table, okay, I'm just going to kind of see. Here it goes up 1. And then on the other one, if I do 434 minus 217, looks like it's 217. So it looks like it's traveling 217 miles in 1 hour. So that's its rate, 217 miles per hour. It says, so the initial values are the same. They both started at 0, but the rate of change for the Chinese train is blank than the rate of change for the Japanese train. I would say it's greater. Okay, because one is going 140 miles per hour, the other is going 217 miles per hour. Okay, it says determine how much farther the Chinese train will travel than the Japanese train. So the first thing they did is they found the Japanese train by substituting 5 in for h for 5 hours. So they took the equation here and they said, okay, I'm going to do 140 times 5. I get 700. Okay, pretty easy. Now let's do the Chinese train. Now it says you could kind of use the table, or let's kind of think we could write the equation for this. It was doing 217 miles per hour. So I'll kind of put that. You could use an h or an x or whatever. So for 5 hours, I'm just going to do 217 times 5. Okay, so if I do 217, I'm just grabbing my calculator, times 5, I end up with 1,085. Okay, so that's how far the Chinese train goes in 5 hours. Now it says, well, let's subtract them to figure out how much further one goes than the other. So I'm going to do 1,085 minus 700. I get 5, 8, 3, so it looks like 385 miles further after 5 hours. All right, let's try the check on page 287. So same kind of thing. It says, suppose that you want to decide which movie streaming service you should join. Okay, this is a real life kind of problem. Company A charges $1.50 per movie with a startup fee of $5. Okay, Company B is shown in the table. Okay, so right away, I'm just going to come over here and I'm just going to label that this is Company B so I know that, since it said that was shown in the table. Okay, it says, first of all, compare the initial values and the rates of change. Okay, so I'm going to come off to the side. You guys, wherever you guys have space, you can do this. I'm just going to kind of list what I know about Company A and Company B. All right, so Company A, if it's got a startup fee of $5 and charges $1.50 per movie. Let's see if we can write an equation. So y equals, it's $1.50 per movie. So I'm going to put $1.50 x plus the initial startup fee is $5. Okay, I just wrote an equation for Company A. All right, how about Company B? Let's look at this one. Okay, Company B, we're going to have to do a little bit of work here. Okay, so I can go ahead and see that this is going up 4. This is going up 2. Okay, so 4 over 2 is the same as 2. So it looks like they're charging $2 per movie. So I'm going to write y equals 2x. And if I want to find the initial value, there's a couple of ways you could do it. You could actually, if you guys notice how it's kind of going up by 2 each time here, going up by 4. What if I went backwards? That would get me to 0, right? I should write that in a different color so you guys can see better. That would get me to 0, and if I went back 4, that would get me to 4. So it looks like the initial value is $4. Now, if you didn't like doing it that way, you could have said, all right, y equals mx plus b. You know the slope was 2, and then you would plug in a point. Maybe I would do 6 and 16 plus b. I get 16 equals 12 plus b. Subtract 12. Again, this is just kind of quick. And then b equals 4. Okay, which is what I got. All right, so now I have both equations. So it says compare the initial values. Well, let's look at their initial values. One company charges 5, one charges 4. So it looks like company A has a higher initial value. Okay, how about their rates of change? Well, their rates of change, if I kind of look at this, company A charges $1.50 per movie. Company B charges $2 per movie. So I would say company B has a higher rate of change or slope. Okay, now that we did that, let's go to part B. Part B says, how much more will company B cost than company A if they rent 15 movies? So I need to find the cost for 15 movies. So I have company A and company B. So I'm going to pause the video. I am going to do company A for you. I want you guys to do company B. All right, company A, you guys can see I did the work for. Now company B, you guys should have done. You should have done $2 times 15 plus the $4 fee. Well, 2 times 15 is 30 plus 4 is 34. Okay, and company A charged $27.50. So it says how much more? Well, I'm going to have to subtract those two. 34 minus $27.50. Okay, again, you guys can use a calculator for that, but 34 minus $27.50 ends up being $6.50 more. So company B would charge $6.50 more. All right, let's take a look at example 2 on page 287. If you would want to try this one on your own, you can, and then push play. So it says Angela and Benjamin each have monthly cell phone bills. Angela's monthly cell phone bill costs 15 cents per minute plus an initial fee of $49. Benjamin's cost is shown in the graph. So I've got Benjamin over here. All right, now I am not going to use all the words on the page. I'm just going to kind of do this on my own. So it says compare the function's initial values and the rates of change. Then determine the monthly cost for Angela and Benjamin for 200 minutes. So kind of a bunch of steps on this one. All right, so again, wherever you can fit it on this page, just let's try to fit it. So I have space here. I'm just going to write it here. You guys can fit it wherever. So I'm going to start by writing Angela's equation. So I'm going to say, well, Angela's is, she has 15 cents per minute. So I'm going to put 0.15 cents per minute. You could use an M if you wanted, but I'll just use an X. Plus, she had an initial fee of $49. So I kind of have her done pretty well. Let's go to Benjamin now. I'll just put Ben. All right, now Benjamin's, okay, it's kind of nice. You guys can see on the graph, you already can see his initial fee. It's $60. Okay, so I'm going to put Y equals something plus 60. It started at 60. Now, I'm going to choose 2 points from my graph to find the rate of change. Doesn't matter which 2 I choose. I'm going to use those 2 I just marked in blue. So I'm going to subtract the Y's. I'm going to do 72 minus 60. Again, you should fit this somewhere on your page. And then 120 minus 0. Okay, so I subtracted my Y's, subtracted my X's. All right, so 72 take away 60, you guys should be able to do that, is 12. And then 120 minus 0 is 120. Okay, last thing, when you type this in, do the top divided by the bottom. So 12 divided by 120. That actually gives me 0.1. Now, if this is money, I'm going to add a 0. So 10 cents. So it looks like Benjamin's rate of change is 10 cents. So I'm going to come down here and say, well, his is 10 cents per minute. So I'll put an X there. All right. Now, here's what I have. I have their equations. So it says, can you compare their initial values? All right, let's look at their initial values. Well, Angela charges 49, Ben charges 60. So Angela's is obviously lower. Okay. Then their rate of change. Well, Angela's is 15 cents a minute. Ben's is 10 cents a minute. So Ben's is a little bit lower for the per minute. All right, last thing it asks us is how much will it cost for each of them for 200 minutes? Okay, let's start with Angela. Angela is 0.15 cents a minute. And for 200 minutes, I would times by 200 and then add 49. So why don't you grab your calculator and let's do 0.15 times 200 and then add 49 to that. It looks like I get $79. Okay, pause the video and I want you to try Ben's. How much will he earn? All right, if you tried Ben's, you should have done 10 cents times 200 and got 20 plus 60 is 80. So I have both of their costs for 200 minutes, and it looks like they are pretty darn close. Ben is 80, Angela is 79, so Ben costs $1 more for 200 minutes. So if you were choosing between plans, if you think you're using about 200 minutes, it'd be pretty darn close. After that, then you could kind of figure it out too. All right, I want you guys to try the check on page 288. When you are done, you may push play and I will have the answer on the screen. All right, for the rest of your task for today, please go to Schoology and make sure you complete everything that is listed in Schoology and follow those directions.